Welcome. My name's Brian McClellan. I'm a senior engineering manager here at Chef. I'll introduce myself a bit here, tell you about how I got to be here and why target mode is relevant to me. I started in tech mostly building dial-up ISPs in the era that people were building dial-up ISPs before they were commoditized. After they got commoditized, and it wasn't like a bunch of people building them in a closet anymore. I started working in IT and started doing operations for websites and the growing internet thereafter. I moved to Seattle. I grew up in Maine. I live in Maine again now, but I moved to Seattle for a while. I started working in web operations. Eventually I met Adam Jacob, and I got grumpy about automation. I got involved with Chef with him. That was the DevOps era. I've been working at Chef for about 10 years now. Working on Chef for 10 years, working at Chef for 9. And for the last 5 years, I've been a manager at Chef, and so most of my time is spent taking care of humans, but I still spend a lot of time working on Chef and other projects in that ecosystem. I have a lot of hobbies as well. That's me learning how to stop a sprinkler when I went through the fire academy. I'm a volunteer firefighter in my hometown. That's a fun experience. This is an actual, around when I started using configuration management, this is an actual rack at a company that I had just been hired at. And this is both literal and figurative of the problems that need to be solved with configuration management. So no one could tell me what any of this equipment was, where any of the servers were, how they were built. And a lot of the time I spent there was figuring that stuff out and documenting it. And that was at the same time that I got introduced to configuration management. We used another tool for a little while. Things didn't work out, and we wrote Chef. And so Chef was really written. A lot of the early providers and resources in Chef existed because I needed them to fix this. The important things that we got from this was that, so for repeatable steps, we had a QA cluster, we had a dev cluster, pre-prod, prod clusters. All of them were different, which kind of defeated the purpose of having those there, right? They were all built by hand. Somewhere there was a Word document that said how to build it, but they were built at different times, so they had different versions of software. And they weren't consistent. Another one of the problems that we had there was that we had a QA cluster. Everyone wanted to use it because there's only one, and it was really hard to build it. So we had no way to build another one at speed. And configuration management gave that to us. We could build repeatable environments at speed, both locally and eventually. This was when Amazon EC2 started growing around the world, and we expanded into other EC2 regions across the world. So I mentioned Chef's been around for 10 years. We've learned a lot of really interesting lessons about Chef over that time. As a system administrator before becoming a developer, a lot of the work that I did in Chef was at the intersection of Chef and the operating systems. And that also meant a lot of the packaging. And so when we first released Chef, we were shipping it as a gem. It was very difficult to install on lots of different platforms. It was even harder to support on lots of different platforms because they were all different. We started building native packages like Jebs, RPMs, Debs. We wrote the Omnibus project, which is how we build our software, almost all of our packages today, which build the fat binaries that you download and install. And these days, we are switching all of our software slowly to build under our Habitat environment. If you've been using Chef for a long time, you might remember things like definitions and which you can no longer use, but the progression of how We've refined writing resources to make them easier and easier for people over the years, and that's changed. One of the most difficult things about building Chef is all the platforms that we build it on and have to support. We have, in our pipelines for Chef and Chef Decay, we have hundreds of systems in our CI/CD pipeline just to build and test Chef. Some of those are very strange, and the stranger they are, the harder they are for us. We build on AIX, that's very difficult. We build on an architecture called S390X, which is a mainframe at a university somewhere. We have SSH access to it over the internet, and the internet doesn't work well, and it breaks our pipeline. Those are the two. We also build on Solaris. These things make us unhappy. Those edge cases are part of what I'll be talking about today, though, because those edge cases are always the most difficult, and they're the ones that are easiest to say, well, we're just gonna do that one by hand. I'm just gonna, write down on a piece of paper how I did that one. If you want to know more about those things that we don't like, some of our release engineering folks are doing a talk after this in 401 at 3 p.m. And you can learn about Expediter, which is an internal tool that we use that we all really like. But when we talk about automated infrastructure, coded infrastructure, this is more than just our servers, right? This is, our infrastructure includes our routers and our switches, storage devices, all kinds of other equipment. Managing those has been hard, particularly with Chef and other automated tools. Early on, we kind of cheated and we're like, well, Amazon has an API. We'll just use their equipment. And we'll just use their API in our switches and their API in our cookbooks and recipes. We did make attempts. Let's see. We did make attempts over time to support different types of switches and routers with Chef. There were one path that we did was there's a number of devices that actually really have Linux underneath them, like Cisco NXOS, and I think there's a Juniper switch that we supported too. And we built native builds for those for a while. But if AIX is hard, those builds were even harder. They're really hard to do anything to benefit everyone on your Ubuntu build of Chef and still not break the build on Cisco NXOS from, God knows the last time they updated their dependencies on their platform. We also had another path for a while where we had some cookbooks that supported other devices through their APIs. And so, like I mentioned, Amazon EC2 before, that worked out pretty well for us. But one of the big lessons learned over time is that keeping cookbooks up to date with the core Chef client has been difficult. And so one of the things you'll see if you read all of our release notes, you pay attention to what we're doing with Chef, we've been moving more and more resources into core Chef so that as you update core Chef, you get those new resources, they're always working. You don't have to worry about a mismatch between a cookbook and which version of Chef you're using. So we're going to take that further, and what we're going to do is support more devices in Chef. But as I indicated, I don't want to build Chef on those devices. And many of them you can't, right? They don't actually have Linux underneath. Maybe they are Linux, but they're an embedded platform. So you don't want to put our giant fat binary on them. And so the way that we're going to do that is with target mode. We've talked about doing something like target mode for quite a long time. We've had a couple attempts at it, and I think that this is the right one. The biggest benefit of target mode is that target mode is a normal Chef Infra Client run. So it's just like anything that you do today with Chef. So Chef runs, it's the same binary, it's the same code paths. It creates a node object. It has a client key. It has resources, recipes. The difference between a target mode run and a regular Chef client run is that we use our train library, which we've been, as an aside, if you use Chef 15, with Chef 15, we rewrote the bootstrap code to use train. So we've been consolidating a lot of underlying libraries lately. We'll continue to do so over future Chef 15 releases. So the train library is a library that we use with inspec today. That is what inspec uses to SSH or WinRM out to your other servers and run commands on them. And so target mode uses train to talk to a remote server. And the way that we configure target mode right now, today, is with knife profiles or a Chef credentials file. And I always think that we've documented knife profiles. I'm pretty sure we haven't. I can't find the documentation. There is an RFC, RFC 99. And because I think knife profiles are such an important undocumented feature, I want to go over them for a second with you. So for a long time, those of us that have managed multiple Chef servers, multiple Chef organizations, what we've done is we've had, you'll have multiple Chef configuration files, right? And you type knife node list -c and some file. Or at Chef for a long time, we had a lot of Ruby hacked into our client RBs and config RBs so that we could use environment variables to switch which files loaded and what the organization name was and stuff like that. And so knife profiles was meant to replace that. And this is a TOML file that you create called credentials in your .chef directory. And the keys here are the same keys that would be in your client config. So node name, client key, Chef server URL. And so what this allows is if I did a knife node list, it would use the Chef server in the top block, the api.chef.io bedrock organization. But if I said knife node list -- profile dev, it would use the bottom Chef server, the bottom credentials. And so obviously when you're starting to use target mode and you need to talk to other devices, those devices, you're going to need different SSH keys for them. You're going to need different usernames. Maybe you need to store the password somewhere. So rather than create something else, we leveraged knife profiles for that. And so for target mode, in the same file, you can specify usernames, passwords. For Cisco devices, you can specify an enable password. Other keys that you put in here in target mode get passed directly into train. So if it's a configuration that train knows, like port or protocol, you can put that in here as well, and it would get passed through here to train. The biggest caveat with this is that TOML doesn't like the periods in the group names, so you have to put single quotes around your host names, your FQDNs, if you put FQDNs in here. I'm pretty sure target mode catches that and warns you now, though. So Chef 15.0 was released recently. This has experimental target mode in it. This version of target mode supports the execute resource on remote systems and the resource guards, like only if and not if, work in target mode. Particularly, you can use a not if block to run a command on the remote system. If you used a resource guard with a block of Ruby code, that Ruby code would still execute locally. Converting other resources to target mode is pretty easy. Right now, we have some helpers in Chef called train or shell. And the idea of train or shell is that if you're in target mode, it will run a command out over train. And if you're not in target mode, it'll run that command locally using mixlib shellout. So converting the execute resource to use this was just a matter of going and changing those shellout lines to this. If any of you have written resources before, Notably, this is experimental, and we already have plans to replace trainer shell with something else. So that probably won't be there in 15.1, but as target mode continues to grow, there'll be more information probably on discourse about where we're going with it. But you can use target mode today to write a custom resource. The way that a resource supports target mode is you put target mode true as displayed here on the provides line in your custom resource, and Chef then knows that that resource supports target mode. If it wasn't there, you would get, and you tried to use a resource over target mode, you'll get an error saying that Chef couldn't find a valid resource. So target mode's interesting because for many years, people have been saying, I want to configure my network switches. And I always ask them, well, what do you want to do on your network switches? Like, what is it that you would do tomorrow on your network switch that you want me to automate for you? And the most common answer I get is, well, it's not actually me, it's the network guys, and they're complaining about it. I'm like, well, you should get them to call me. And this has gone on like this for years until I actually wrote this at the Community Summit in London last year because I had that conversation one too many times. I was finally like, all right, we'll write the experimental target mode and it'll be out there. And then hopefully what's going to happen is someone's going to try to use it and say it doesn't do the thing that they need. And then I'll know what the thing that they need is. So please use it, because otherwise my scheme doesn't work. But we're looking into, we're going to have to do a bunch of refactoring inside Chef to make the file resource work over target mode. It's kind of a big project and involves a bunch of tech debt that we really should clean up. So that's a big project. We're talking about that, looking at that. One of my goals with target mode, though, it's not just for network devices. It's not just for your switch or your routers. It's also for managing other systems. Other systems that maybe you could install Chef on today, but maybe you have a policy in your company that doesn't let you install software on a system that you want to manage. Or your security team lets you install software, but Chef's too big and they don't really trust how much is inside it, right? You could use target mode to manage that system remotely. Maybe as a developer, you've got a bunch of systems that you have a user account on, but maybe you don't have root on them and you want to get all of your personal .dot files and your shell set up. You can run Chef Client without root on systems as long as you're not trying to manage anything that requires root. So you could use remote file to set up your home directory on all your systems. An exciting one for me is that if you have a system that is an architecture, maybe you have Red Hat, but it's on some architecture that we don't have a build for. Rather than us trying to make a build on that, you can manage it using target mode remotely. So those more esoteric architectures that we don't have builds for today automatically become supported with target mode once we have support for those resources. So the second bullet point here is that as part of the file, after the file resource, I want to get every resource that you would use on Ubuntu to work with target mode so that you could completely manage an Ubuntu system. The most common platform people use with Chef is Ubuntu. So we'll start there, and along the way, this will take 6 months probably to get through all of this. Hopefully we'll get some use cases. You may have heard of RFCs before. I mentioned RFC 99. That was a process we used to use for proposals for modifying Chef. And we've switched to just all of our projects as part of open sourcing all of our software this year, use a new process called design proposals. In short, you just go on GitHub and you create an issue and say what it is you think we should build. So if there's a use case for target mode that you run into, the best place to talk about it is on GitHub issues for Chef. And I look forward to hearing from you. So I've got 2 demos of the execute resource. developed the Cisco support of the execute resource on this giant 2960 that I had lying around my house. It's got really loud fans, it's hot, and it doesn't fit in my baggage. So I bought this little 3960, and it doesn't have fans, and I was a little worried. My baggage actually made it. The TSA did not confiscate it. So if I want, I'll show you the configuration real quick. This is my credentials file. I have a Chef server running on a VM here. I have this switch on my Ethernet port. I have another VM here, an Ubuntu VM that I'll show you target mode against that too. It's the same. But that's funny. My date skewed. Hold on. Well, that's starting up. On the screen you can read. So this is the demo recipe for a Linux system, and it's obviously pretty simple. We're going to create a file on the remote system, and we're going to use the guard to not create it if the file already exists. And the Cisco one's a bit more complicated. Mostly, it's not complicated if you're familiar with Cisco's, but because this is just an execute resource, all this does is run commands on the Cisco device. And to be able to configure the device, there's a number of hoops we have to jump through on a Cisco device. But what this does is it changes the VLAN for a particular interface to another VLAN. I think it's set to 3 right now. It'll change it to 5 and then save that configuration. And for the guard here, we're using that trainer shell helper to show the configuration and see if it's already set to that. It's quite crude. Oh, time zones are hard. GMT -4. That's close enough. That lack of output is actually success. So as I was trying to show you 5 minutes ago, the local Chef server doesn't have any nodes on it right now. Probably has a validator client. So this is the command line syntax for target mode, -- target, and the host name. The unique thing about what target mode does is that it creates separate directories for all of your local configuration files and cache files. So you could have a workstation or a jump box that runs Chef Client daemonized and manages 10, 100 devices depending on your splay, and the size of your hardware. So since target mode uses train, we get the platform names and data that comes out of train. So we know that that system is a Ubuntu 18.04 machine. Unfortunately, some of the train data is slightly different than what Ojai uses. And that's another large refactor project that we'll be working on in the near future to better align train and Ojai. And as part of that, that'll facilitate what we call remote Ojai. So right now, I don't have the amount of data that I would have on another Ubuntu system that actually ran Ojai on it, because the only thing I'm gathering is the data that train gives me. So I'm adding the execute recipe that I showed you earlier to that node, and then we'll run again. So the first time that I ran, the local Chef client created a node object. It created a client like it would if you were bootstrapping a system. I added a recipe to the run list, ran Chef again. It created a file. The execute resource created a file. Run it again. Because the guard supports target mode, it'll be idempotent that time, and not run it again. Yeah, there's the file. Anyway, and so for the Cisco switch, it works the same way. Fortunately, the Cisco switches are kind of slow. Probably should have had a story to tell you, but so the only thing that gets run on the switch itself, let's see, train runs a few commands. They're built into train to try to identify its version of OHI, to identify what it was. But the only other commands that get run out there are the commands that were in my recipe, of which there aren't any yet. But you can see that we detected that as a Cisco platform. There's a node object for it on my Chef server. I'll add that recipe to the run list and run again. I'll actually check and see what the VLAN is set to. If you want to follow along. That's 3. Needless to say, this will probably work. So while we wait for it, does anyone have any questions?
How expensive is it to run a target memory versus your traditional converge?
Yeah, it's exactly the same. I mean, it is a traditional converge. It happens that instead of, there's target modes, it's actually a pretty small change, and it's mostly to paths and stuff like that. But ultimately, the change to resources and providers is that we just, instead of running the command, like you would run apt install for a package resource, that would get run on the remote system instead. The performance really ends up being train and the remote system. So train does try to reuse connections, SSH connections. Remote OHI is difficult because we run a lot of commands. And so as we start writing remote OHI, we have to probably figure out the right size of a parallel pipe to run a bunch of commands. But target mode itself is the same performance as a regular client run. Baked into kitchen. Sure. Probably. Yeah. That would be an interesting experiment. Oh yeah. Yeah, I wrote a lot of the early Windows resources. I was a MCSE back. I don't know if those are even still things, but I'm a Windows person and do a lot of the Chef Windows support. Yeah, we'll definitely get to that. Yeah. Questions? Yeah, it reports back to back to Automate, right? Yeah, the same thing that would happen locally. It goes out and hits the Cisco SSH is questionable. It goes out and hits the same data collector API, yeah, at the end of the run. No, that's changed. Well, in terms of target mode or just in terms of data collector? Yeah. So it's independent of target mode, but you can take a Chef client configuration, put in a data collector URL directly to Automate. Yeah, and a key, yeah. Yes, and the guards, yes.
Are there any plans to build target mode specific resources, like actually just nice wrappers for configuring, say, Cisco Support configurations?
Yeah, I was thinking, well, so the two things that have come to mind for me for use cases from my life were VLANs. There ends up being a question like, it's an interesting topic. So what do you want to configure on your Cisco switch? Like, I wouldn't want to configure the whole thing because like, I don't want it like, you risk network connectivity losses and stuff like that, right? I might want to have some sort of Cisco resource for initially dropping a whole config, and that would just be like a config resource, right? But beyond that, it's just VLANs and users were the ones that were, sticking out to me. Like port speed and stuff like that. I think Cisco's like finally stopped making their auto negotiation terrible, but I still have like a muscle that wants to manually set that stuff. This is actually too slow advice, I guess. But yeah, users were the next one I was thinking about. Like, and of course, what's cool with Chef is you can write a cookbook with a custom resource to, for Cisco user, and it'll just work. Yeah, this is something that Chef is doing by itself. And it's not Cisco specific, right? So we've partnered with lots of, who was it? Well, we partnered with network device companies in the past, like when we had NXOS builds for Cisco, right? This does put some of those partners in the past, they've managed cookbooks for their own equipment, and this would put Cisco or another partner in that same scenario where they could write a cookbook to manage users or whatever they wanted. But Cisco is just what I'm familiar with, so that's why I'm using it.
Is there any timeline for a release to general support or going outside of an experimental mode?
As soon as it's validated by people that want to use it. Like, the biggest part of it being experimental, I mean, obviously it only does the execute resource today, but is that I need the interface to be validated as useful to people before, because once we call it experimental, then I sort of can't change the interface for 12 months. Yeah. All right. Yeah, thank you.